Hello, my name is Aiden Massey, and this is my Mech 447 project on nuclear as a source of carbon-free energy. Why do we need to decarbonize? In 2015, 195 countries agreed to aim for a total of 2 degrees Celsius of global average warming at the COP21 summit. This limits the remaining cumulative CO2 emissions between 2015 and 2100 to 1,000 gigatons of CO2. This means that we have a carbon budget. So why should we use nuclear power? Nuclear is a carbon-free energy source. Recent advances in nuclear technology have made them safer than they have been previously. The World Nuclear Association has created a 2 degrees Celsius projection for nuclear technology from 2012 up to 2050. They project that the percentage of nuclear capacity generation capacity will increase from about 10% in 2012 all the way up to 18% in 2050. What are some of the characteristics of nuclear reactors? Nuclear reactors typically have a very high capacity factor, as can be seen in the graph below. We can see ranges of capacity factors from 73% all the way up to 92%. Nuclear is a dispatchable energy source, which means you can ramp up and down the output easily. Nuclear requires a highly skilled workforce. After the high initial cost of building a nuclear reactor, there are low operating costs due to the low cost of fuel. So how much nuclear does the world have right now? This graph shows the nuclear generation capacity globally from 1955 up until 2015. We can see that there was exponential growth in nuclear generation capacity up until about 1987, and then we started to flatline. So why did nuclear stop growing? It was largely due to the meltdown of several reactors around that time. Part of this was the nuclear reactor meltdown at Fukushima. This caused a lot of fear in the public, and the fallout was a lot of phase out of nuclear reactors throughout the world. This was spearheaded by Angela Merkel in Germany, who decided to phase out 17 nuclear reactors in Germany by the end of 2020. Another reason nuclear has stopped growing is because the public associates nuclear with weapons technology. This graph shows that most of the projected growth of nuclear power is happening in China. We can see that in the red band, that's causing most of the growth throughout the world up until 2040. So what are the challenges in implementing nuclear power generation technologies? Right now, nuclear power has a high initial cost. There's also the topic of storing nuclear waste created in nuclear reactors. Nuclear reactors also have a very expensive decommissioning process. In addition, nuclear reactors cause several public safety concerns. This graph shows some of the decommissioning happening with nuclear reactors in the United States. The dark blue shows decommissionings that have been complete on reactors. The light blue shows decommissionings in progress, and the red shows the storage of nuclear waste at certain nuclear facilities. We can see that The average decommissioning time for a reactor is approximately 7 years. What are some of the new nuclear technologies available? One of the recent ones is small modular reactors, which could be used for industrial applications in remote locations. Another not exactly new technology is the CANDU heavy water reactor. These reactors are being adopted in China and India. Another technology is a fast reactor, which can burn some of the extra waste produced in conventional pressurized water reactors. So will nuclear make a comeback? In the above graph, we can see the 2 degrees Celsius projection for nuclear growth globally, and below we can see a projection created by the U.S. Energy Information Association, showing what track we are on right now. In the 2 degrees Celsius prediction, we can see that they expect by 2040 to have a total generation capacity of 800 gigawatts, whereas in the US projection, we can see that they project only 500 gigawatts total capacity by 2040. This means we will probably not make the 2 degrees Celsius projection, and nuclear growth will not be that steady. Thank you. This has been a look at nuclear technology as a source of carbon-free energy.